Good day, grade 12 learners. Welcome to today's technical science lesson. My name is Musa Zulu. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Grade 12, welcome to term 2. Let's try and get ready for our half-year examinations. Right, grade 12, today we're still doing matter and material as our knowledge area there. And our topic again, we're still doing organic chemistry, trying to finish off here the organic chemistry. The last part there of organic chemistry being the reactions of organic compounds. So today we're going to be focusing on the reactions and the type of reactions that we need to know of organic compounds. Right. So by the end of today's lessons, we are expected that we must be able to write down a chemical equation for the combustion of hydrocarbons in excess oxygen. You must be able to identify reactions as addition or substitution reaction. We must be able to write down using structural formulae or molecular formulae the chemical equations for either an addition reaction or a substitution reaction. You must also be able to write down the conditions for all these reactions, being the combustion reaction, the addition reaction, and also the substitution reactions. So that's what we are going to be trying to be learning today for this lesson. Right. Our pre-knowledge is that what we are expected to come to this lesson knowing, we must be able to define hydrocarbons. And then we're going to go back a little bit to grade 10 when we were being introduced to writing molecular formulas for oxygen, carbon dioxide, and water, and also for writing chemical equations and also balancing chemical equations. You remember that this grade 12, we did a lot of this in grade 10. This was a chapter in grade 10 or a topic in grade 10 where we had to write chemical equations and also balance them. And we cannot be writing chemical equations without being able to write chemical formulas for such compounds or even atoms, oxygen, carbon dioxide, and water. So if you are able to do this, write these molecular formulae for these compounds and also write chemical equations and balance them, you should be fine for today's lesson. But if not, we're going to try and help you remember all those things and how to do them. Right. So for our baseline assessment, the grade 12 would ask that you try and define the term hydrocarbons that we have looked at here from our first lesson of organic chemistry. And number 2, write down the chemical formula for oxygen, carbon dioxide, and water. And the third question there is balance the following chemical equation, which is Mg magnesium being added to oxygen gas, giving us magnesium oxide there. So the expectation is for you to try and balance the following chemical equation. Okay, so if you know these answers, you should be able to say the definition of hydrocarbon is hydrocarbons are organic compounds that consist of hydrogen and carbon atoms only. This only there being very, very important there as the key word of this definition. Without this definition, if you say hydrocarbons are organic compounds that consist of hydrogen and carbon atoms, then you are not correct. You must say hydrogen and carbon atoms only. The word only must always appear there. It's a key word in this definition, and the definition is taken directly from the examination guideline, as I always stress that definitions must be taken from there. Number 2 says write down the chemical formula for oxygen or oxygen gas, carbon dioxide, and water, because we are going to need to be able to write these chemical formulas for these substances grade 12. So for oxygen, the formula there is O2. You must be able to write that. Know that oxygen is O2, oxygen gas. That's oxygen gas in full there. Should have said oxygen gas. And then carbon dioxide there, that is CO2. Also there a gas, carbon dioxide, CO2. Capital letter C and a capital letter O, by the way. It's not a capital letter C and a small letter O. Let's avoid making that mistake, grade 12. Capital letter C, capital letter O. CO2, carbon dioxide. And then the chemical formula for water is H2O. Very, very important. These are going to be important for this lesson, grade 12. Number 3, balance the following chemical equation. Well, the balanced chemical equation is as follows. You would remember there that in grade 10, when we were balancing the chemical equation, we would look at the equation separately. So we'll start by looking at the right-hand side of the equation and then comparing it to the left-hand side of the equation. For example, when we look at this reaction, we'll say, how many magnesium atoms do we have on this side, the left-hand side of the equation? We'll say here we only have 1. And how many do we have on the other side? It's also 1. Okay, that means they are balanced, since it's 1 this side and it's 1 this side. However, when you go and check the number of atoms of oxygen there, you find that this side, the number of atoms is what? Is 2. But when you go and check the number of oxygen atoms on the right-hand side, it's what? It's 1. Then that tells you that this reaction or chemical equation is not balanced, because the number, even though the number of magnesium atoms are equal on both sides, the number of oxygen atoms are not equal. So the whole reaction is not balanced. So it means everything must be balanced. Trying to remind you of what we are trying to achieve when we are balancing a chemical equation. So what you can then do, you can then say, okay, if that is the case, how about I add an amount of magnesium by making it here 2, right? Because I cannot touch these small numbers there when I'm balancing a chemical equation. So let's change this and make it 2, okay? If I change this and make it 2, I not only affect magnesium, but I affect the whole equation. Because now I have 2 magnesium, but that side I have 1 magnesium atom. So the magnesium now is no longer balanced. I have 2 oxygen atoms here. I have only 1 oxygen atom on the other side. The oxygen also not balanced. Okay. However, if I go on the other side and try to fix what I have messed up on this side by making the magnesium balance and putting a 2 also here, I will find that now I have 2. Let me write it here on the side. Mg plus O2 giving me 2 MgO. Right, now let's check now. Now I have 2 magnesium atoms, and then the other side I also have 2 magnesium. Okay, well, maybe not atoms, but I have 2 magnesium in terms of the amount there. Also 2 on the other side. And when I check the oxygen, it's also O2. So I have 2 oxygens here, and then on the other side I also have 2 oxygens. Now the chemical equation is balanced. Everything is the same from the left hand side to the right hand side. That's the idea of balancing a chemical equation, and that's one thing that we are going to need to be able to do as we go on with this lesson. Okay, right, so this is something that we are expected to know, coming with it from the previous grade, or specifically grade 10, because this was a topic there that was done in grade 10, grade 12. Right, for today, our terminology will be as follows. We want to know oxidation or combustion reaction. These are reactions that occur between hydrocarbons and excess oxygen. Right, when we then go in detail with them, you would understand what we are trying to say when we say reactions between hydrocarbons and excess oxygen. Right, so the explanations that are being given here, they are not definitions, grade 12. I should say that these are not definitions. These are explanations that are specific for us, technical science learners. For us, oxidation or combustion reaction, only for us and for our scope in grade 12 and whatever will be examined. We are just going to be reacting only hydrocarbons and excess oxygen. Doesn't mean that oxidation reaction does not happen with other compounds or other substances. But for us, oxidation or combustion reaction, as I will refer to it most of the time, right, is only going to be between hydrocarbons. And by hydrocarbons, what do I mean? If you remember, it has to be alkanes, the alkenes, and the alkynes. Those are the hydrocarbons. These are the compounds or that belongs to these homologous series are the ones that will be reacted with what? With excess oxygen. for our combustion reaction, grade 12 technical science. Okay, we're also going to look at addition reaction. This is the reaction in which a double bond in the starting material is broken and the elements are added to it. So we're going to have a compound that has a double bond, and that double bond is going to be broken, and then elements, or maybe we should say atoms, are added to it. Okay, again, an explanation that favors us and also favors our what? Our scope, grade 12, to say our addition reaction is only going to be that of a what? A double bonded compound, an alkene, right? It's only going to be that of a double bond for our scope for technical sciences. Hydrogenation is addition of hydrogen to an alkene. So when we adding hydrogen to an alkene, that's we are having hydrogenation there. Still going to look at that in details. Halogenation, the reaction of halogens with a compound, whatever the compound may be. Hydrohalogenation, that's the addition of hydrogen halides to an alkene. Again, grade 12, don't worry if I'm fast now. We're still going to look at all of these things in details, looking at them one by one. Okay, as we continue with our terminology of the day, hydration is one thing we're going to look at as well. The addition of water to a compound, as the word itself says, hydration. When you are hydrating, that you are adding water to something. Substitution reaction, a reaction in which an atom or a group of atoms in a molecule is replaced by another. So substitution is almost like an exchange of atom. This atom moves and then is replaced by another atom, as would happen during a football match. One player goes out, the other player goes in. We call that substitution. Okay. Lastly, the hydrolysis. That would be the reaction of a compound with water. If you react a compound with water, you are going to be having a reaction called the hydrolysis. Okay. Right. So let's try and look at each of these reactions, hoping that time will allow us to finish all of them one by one, starting with the combustion reaction. Okay. Now, the combustion reaction, as we have said, this is the reaction between, for us in grade 12 technical sciences, this is the reaction between hydrocarbons. And you would remember what we said hydrocarbons are. Those are, they belong to alkanes, alkenes, and alkynes, because those ones, they consist of what? Hydrogen and carbon atoms only. And oxygen. So it will be between hydrocarbon and oxygen. It occurs when a hydrocarbon burns in excess or sufficient. These words are important. These are conditions, and also these are keywords, grade 12. These are the words that are going to tell you that this reaction is occurring. Every time you read a question and then they are saying something which is a hydrocarbon is burning or undergoes combustion or undergoes oxidation, and then they said in excess oxygen, or they say sufficient oxygen, or they say enough oxygen. That is a clue to you to say that reaction they are talking about is a what? A combustion reaction, grade 12 learner. So those words are very, very important to keep in mind. Excess oxygen, sufficient oxygen. Sometimes they use the word enough oxygen to say there is enough oxygen for the reaction to occur, because this oxidation reaction will never proceed without excess oxygen or without sufficient oxygen. There is never going to be combustion reaction without sufficient oxygen. So you must always keep that in mind, right? For combustion reaction to happen, there must be enough oxygen. You would remember, if I make an example, what we are actually saying here, grade 12, is that you cannot, in general terms, you cannot burn something without having enough oxygen. If you're trying to burn something and then you cover it up, like trying to burn a match and then you cover it up like this, it's going to extinguish itself. Why? Because you are depriving it of enough oxygen. So for something to burn, there must be enough or sufficient or even excess oxygen. So this condition is very, very important for this reaction. Okay? This reaction always produces carbon dioxide, water, and energy. So the product of this reaction, we have talked about the reactants as if what is needed. We need hydrocarbon, we need excess oxygen. Then they react. The product that are going to be formed there is going to be carbon dioxide. Then you're also going to form water, and also there's going to be energy. But most importantly, take note of carbon dioxide and water. These are the ones that we are going to be representing when we are writing down our chemical equation. As we have said again before, the condition for this reaction to take place is that there must be excess oxygen, there must be sufficient or enough oxygen for this reaction to take place. Without excess, sufficient, or enough oxygen, the reaction does not take place. No combustion is going to take place in that case. Okay, so the reaction, when you're writing the chemical equation, will always take the format hydrocarbon, whatever hydrocarbon is undergoing combustion or burning, right? Plus O2. Then you are always going to have the product CO2 plus H2O. I cannot stress this enough, grade 12. This part of the reaction will always be the same. This part of the reaction does not change. The only thing that will ever change in a combustion reaction is the type of hydrocarbon they've decided to use for that particular question. The examiner will choose any hydrocarbon that is within alkane, alkene, and alkyne. However, the next reactant is not up to the examiner. It's always going to be O2 as long as we are talking combustion reaction. It's always going to be O2, and the products are always going to be the carbon dioxide, CO2, and water, H2O. So we must be able to remember that always. This part of the reaction does not change. Okay, the reaction must always be balanced. So after you have written the reaction, say, then they've told you a certain organic compound is undergoing combustion, and then you must write the chemical equation. After you've written the chemical equation, whatever the hydrocarbon they have used plus O2 gives you CO2 plus H2O. After that, you need to balance that chemical equation. I feel I should stress this again, right? H2O, CO2, O2 do not change in the oxidation reaction, grade 12. They are always going to be there. They are never going to change. The only thing that will change is the hydrocarbon, the type of hydrocarbon. They could use, for example, a propane. They could use, for example, a pentane, right? They could use, for example, maybe a butane or butene, right? Any hydrocarbon they could use. However, they are not going to change this other reactant, and they are never going to change the product. These ones are always going to be there. Always, always, always. This is why I am having this always here in capital letters. And we are saying the reaction must be balanced. Okay, so this reaction is one of the most simplest reactions that we can come across. This reaction is usually 3 marks in the examination, and it's always or almost always there. So I want you to, from today, and say to yourself, these 3 marks I will never lose. Take these 3 marks from today, where you are going to be able to write the chemical equation and balance the chemical equation. So let's look at an example and see how we should do that. So let's take certain steps of doing this and see if we can do it. So look, let's check the example. It says propane burns in excess oxygen. Here are my keywords. Propane burns. Propane is burning. Once propane is burning, that tells me we're having what? Combustion reaction here. But it burns when? In excess oxygen. Another word could have been insufficient oxygen or in enough oxygen. Usually the word that is mostly used is excess oxygen. So propane burns in excess oxygen. And the question says, use molecular formulae to write a balanced equation for this reaction. Okay, so what do you do as a grade 12 learner then? The first thing that I want you to do, grade 12, is go to the hydrocarbon. There's the hydrocarbon they are talking about. It's propane. The first thing I want you to do is draw the structure of the propane. Okay, why are we drawing the structure? Because they said the molecular formula. I'm going to show you very quickly here. First thing, let's draw propane. Propane is prop, that's 3 carbons. 1, 2, 3. Propane, look at the name ending there. If you remember our R5 catch table, name ending says ane or ane. Ane tells us we are dealing with an alkane here, and an alkane always have single bond in between the carbon atoms. And since it's an alkane here, we are now going to make every carbon satisfied. And carbon is satisfied or happy when carbon has 4 bonds around itself. Then we are going to give this carbon hydrogens. Please, 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 let's ensure that we do not forget to indicate our hydrogens, our bonds, and we indicate the correct number of hydrogens. Don't forget, maybe you end up not putting in this. Always check that. Common mistake that everyone can make. So let's always make sure. Now, once you have drawn the structure, it is easier for you to write the molecular formula of an organic compound after you have drawn the structure. That's why I always say people must start by drawing the structure. Don't just go and try and write it down. Draw the structure. And I know some of you even know of general formulas. If the general formula works for you, it's fine. However, I still emphasize the most basic thing that you can do is always draw the structure. You can just look at the structure if you've drawn a correct structure, then go calculate from there. How many carbons do I have? It's 3. You write C3. Okay. How many hydrogens do I have? Physically count them. 1, 2, 3, 4, 5, 6, 7, 8. And I have H8. Okay. That's the only difficult part of the reaction, as I've said. The next part is always going to be the same. So I'm now going to add this to a what? O2, oxygen gas there. And this is always going to produce what? CO2 plus H2O. CO2 plus H2O. By doing this, I already have 2 marks in my exam criteria, because now I have the marks for the reactant, now I have the marks for the correct product. Now I'm sorted. Now I need the last mark, where I am now balancing the chemical equation. Now, if you remember, when we started the lesson, I was reminding you of how we balanced the chemical equation in grade 10, where we had that method of checking how many carbons are here, how many carbons are there. If you remember there, I was changing magnesium, caused me to go and change on the other side. It affects 1, 2, 3. Okay, as much as that strategy could still work here, this is not a strategy I would advise people to use, because there is an even easier one for this type of reaction that I would say people must always go for. Very, very simple strategy, grade 12, that you can use. So the strategy goes as follows. You are balancing this chemical equation, meaning the number of carbons this side must be equal to the number of carbons on the right hand side. The number of hydrogen here must be equal to the number of hydrogens this side. The number of oxygens must be equal to the number of oxygens, right? Okay, so here's how you do it. Okay, you check carbons here. What number do you see here? You see a 3. You go and write a 3. Okay, then you check the hydrogen. What number do you see here for hydrogen? That's 8. Now I want you to divide this number by 2. You are going to get 4. Go and write 4 here. Okay, then say 3 times 2. You are going to get 6, and say plus this 4 that you wrote. Your answer that you are going to get there is going to be 10. And I want you to divide that 10 by 2. You should get 5, and write this 5 here. This equation is now balanced. Okay, there is no need for you to even go over it, but I will go over it with you quickly to show you it's balanced. Okay, you have 3 carbons. Now you have 3 carbons here. You have 8 hydrogens in total. Now you have 4 times 2. That gives you 8 hydrogens. Okay, and here you have 5 times 2. That's 10 oxygens. Here you have 3 times 2. That is 6 plus the 4. That gives you 10 oxygens. The equation is balanced. Simple as that. I'm going to repeat the steps again as to how you do this. You see a 3 here, you write a 3 here. You see an 8 here, you divide by 2, you get 4, you write 4 here. You see 3 times 2, that's 6, plus 4, that's 10. Divided by 2, you get 5, you write a 5 here. The equation is balanced. Simple as that. Okay, right. Let's try another example and let's see if we can now do it together. Okay, so this example says here, ethane burns insufficient oxygen. Use the molecular formula to write a balanced equation for this reaction again. So we're doing the same thing. The only thing that has changed is what? The hydrocarbon, like I told you. This is the only thing they are going to change. The type of hydrocarbon that they are burning or combusting. Okay, and the words sufficient oxygens are there. The key words that I need for me to understand I'm dealing with a what? A combustion reaction here. So it's if these two carbons, I draw the structure, right? Since it's ethane, there must be a single bond, okay? Then I make every carbon heavy, and you make carbon heavy by giving carbon 4 bonds every time. You make carbon heavy by giving carbon 4 bonds. So now I have a structure that looks like this. I can now write the molecular formula there. What's the molecular formula? I see 2 carbons. So I'm going to have C2. I see 1, 2, 3, 4, 5, 6 hydrogens. So I'm going to have C2H6. The rest is the same. You remember, it's always going to be plus O2, giving us what? CO2 plus H2O. Always, always, always. I repeat, always, always. O2 giving us CO2 plus H2O. No one should not get these 3 marks. Everyone should get these 3 marks. Great off. Okay, now it's time to balance. What did we say? You see a 2 here, you write a 2 here. Okay, you see 6 here, you divide it by 2, you get a 3, you write it here. Then you see 2 times 4, 2 times 2, I mean, you get a 4, right? And then you see plus 3, which gives you what? A 7. Okay, now this one might look like you're stuck. In fact, you're not, because you're thinking to yourself, well, if I divide a 7 by 2, I'm going to get a decimal number, 3.5. And I can't have a decimal number here. We know this way back from grade 10, okay? So what do I do in that case, okay? Take the 7 over 2 as a fraction as it is, grade 12. Write it here, 7 over 2, okay? But this is still not allowed. You cannot have a fraction in a chemical equation and then claim that it's balanced. So what can I do? Now what you are going to do after you've written this as a fraction, you are now going to multiply the whole reaction by the denominator, which is 2. It will always be 2 by 2. So multiply the whole reaction by 2. Now you are going to have the answer is 2C2H6 plus, if you multiply 7 over 2 times 2, the 2's are going to cancel. Then you'll be left with 7O2. This is going to give you 2 times 2 here now. That's 4CO2 plus 2 times 3. That is 6H2O. Now it's balanced again. Very, very simple and straightforward. Let's confirm. 2 times 2, that's 4 carbons. We have 4 carbons here. 2 times 6, that's 12 hydrogens. 6 times 2, that's 12 hydrogens. 7 times 2, that's 14 oxygen. 4 times 2 should give us 8, plus 6 will give us 14 oxygen. Okay, so what I'm going to do here now, I'm going to give you an activity and give you 3 minutes for you to try, and let's see if you are going to be able to get it right. I want to give you a reaction that is going to be burning in excess oxygen, and then I want to see if you'll be able to use this strategy to write a balanced chemical equation like we've been doing. All right, here's your activity. Great job. Your time starts now. Right, welcome back, grade 12. I hope you attempted the question and I hope you got it correct. So let's see here. Our activity is saying use molecular formula or formulae to write a balanced equation for the combustion of butane in excess oxygen. As again I've said, the only thing that the examiner can change here is the type of hydrocarbon that they're asking you about. Remember, even though our examples are just on alkane, it could also be on alkene, it could also be on alkyne. So as long as it is a hydrocarbon, it is possible to be asked, but usually it's just alkanes. Okay, so it is saying butane in excess oxygen there being the condition and the keyword, both the condition for the reaction to occur and is also a keyword to ourselves to indicate to us that we are speaking of here a what? A combustion reaction. So they are saying we must write a molecular formula, right? We want to write a molecular formula, but we are going to start by drawing a structure because it's easier for us to have our molecular formula from structures. So we are going to say it's butane, that's 4 carbons, 3 and 4. And again, it's butane, then that means we have single bonds in between the carbons since the name ending is ane. Then from there, we just simply make our carbons happy, as I usually say. I call this part making the carbon happy. And carbon is happy when carbon has 4 bonds around itself. So let's make the carbon happy and then provide the carbon with the hydrogens. Then from there, we have this beautiful structure. We can now write our molecular formula. Okay, so we are going to say, how many carbons do we have? 1, 2, 3, 4. So that is C4, right? How many hydrogens do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Physically count those hydrogens. Count them. Let them give you the number 10. Okay? Plus, that part going forward is always the same. O2, it's going to give us CO2 plus H2O. The 2 marks in the back. We have the 2 marks in the back. We have the last mark to get now, which is for balancing. Again, very simple mark to get. We shouldn't be saying this one is difficult. Okay, we said we see 4 here, we write 4 here. Okay, we see 10 here, divided by 2, we are going to write, divide 10 by 2, we get 5. So you write 5 here. Okay, then from here you say 4 times 2, that should be 8, plus 5, that should give you what? A 13. Again, we are having that problem of saying 13 divided by 2, it's not going to be a whole number, it's going to be a decimal. However, we do not stress, we take it as it is. 13 divided by 2, write it here, 13 divided by 2. Then from there, what do? We multiply the whole reaction. Remember, if you do this multiplication of the whole reaction, we have to rewrite it down underneath grade 12. You can't leave a reaction with brackets. This is not maths that we are doing here. So you have to rewrite the whole reaction after you've done that. And then you are going to get that it's what? 2C4H10 plus, these will cancel each other. You'll be left with 13O2 because 13 over 2 times 2, the 2's are going to cancel. So it's going to be 13O2 giving us 8CO2 plus 10H2O. In an exam room, you will not even have to stress yourself by checking. This, I am definitely sure, is a balanced chemical equation, grade 12. So that's oxidation or combustion reaction for us, grade 12. Most importantly, are we able to identify the reaction by looking at the keywords, right? Are we able to write the molecular formula of the reaction itself by drawing a structure and writing the molecular formulas of all of the substances involved, reactants and the product? And are we able to balance the chemical equation? And by using this strategy, grade 12, you should always be able to balance and get your 3 marks. 1, 2, and 3 for the balance. Each and every one of you must get these 3 marks. The instruction from me, each and every one of you should be able to get these 3 marks. No one should ever get this incorrect. Very simple type of reaction. All right, without wasting any time, let's move on to the next type of reaction that we are going to look at, grade 12. And the next one is addition reaction. Next type of reaction we are looking at is then addition reaction. Now, an addition reaction, as we have spoken before, is a reaction whereby we are going to be having a double bonded compound, and that double bond is going to be broken, right? Double bonded compound as the reactant, and then it will be broken, and then atoms are going to attach itself to that compound. Simple as that. It's only going to be double bond, so it means we are only going to be having an alkene as the reactant in an addition reaction, right? And an addition reaction, grade 12, will always take the form alkene as compound number 1 plus B, whatever B may be. B is always going to change, and B is always going to be an inorganic compound. There's a question the examiner likes to ask, right? Give the formula or the molecular formula for the inorganic compound in the reaction. And usually grade 12 learners do not know what to do there. The other one, which is not an alkene, is always going to be an inorganic compound in our addition reaction. That's going to be an inorganic compound there. And then you are going to form one product, which is just going, we can represent there as C. Okay? Now, the problem with addition reaction is that we have a lot of types of addition of reactions. Specifically for ourselves, we are going to be looking at 4 types of addition reactions, grade 12. Okay, so we must know all these 4 types of addition reactions, and we must be able to identify them. See, this type, and the next one is this type. And how are we going to do that? We're always going to identify it by looking at what? At compound B, because compound A, or this compound, will always be an alkene. Always be an alkene. So this one, the compound that it is reacted with, is the one that is going to tell us what type of addition reaction are we talking about here. Are we talking about this one, or this one, or this one? Okay, let's look at the type of addition reactions that we need to know. Number 1 is hydrogenation. Okay, I always say to my learners, hydrogenation says it's coming from hydrogen and nation. Okay, so to me it says this is a nation of hydrogens. Hydrogenation, a nation of hydrogen, meaning I'm always going to find what? Hydrogens when I'm talking about hydrogenation. Halogenation is the second one. Same thing. It must be halogen and a nation. Halogenation, a nation of halogens. You remember halogens, we spoke of them there, the chlorines, the bromines, right? Could also be the fluorines and the iodines, but most of the time it's going to be chlorine and the bromine, which is what I'm going to be focusing on here. Okay, that one type of addition reaction that we must know, hydrohalogenation. So we are now having a mix of this nation, where we are now having hydrogen, halogen, which is, and then nation. So it's a nation of both hydrogens and the halogens. That's where you are going to be having your HCl's, or you are going to be having your HBr, or it could be HF or HI, even though these ones are not mostly asked. We are going to be focusing on HCl and HBr. And the fourth one there is hydration. And we already said that when you are hydrating, you are adding water. Hydrating something, you are adding water to that particular substance. So hydration will be, or we will see it by the addition of what? Of water. As I said, this B is always going to tell us what type of reaction are we talking about. So if B is just hydrogen, a gas, that means we are talking about hydrogenation. If B is a halogen, will be Cl2 or Br2, that means we are talking about halogenation, because there's a nation of halogens that is being added to an alkene there, right? And then if B is either HCl or HBr, Now we are talking about a hydrogen and a halogen. That has to be hydrohalogenation. Lastly, if B is H2O, we are adding water into something, that must be hydration. So that's how you would identify this reaction. Okay, but identifying them is not enough. We should be able to identify them, but we also should be able to write their equation or chemical equation structurally or by using what molecular formula. So if you can do it structurally, the molecular formula should be easy because you will be able to take it from the structure itself. Okay, so let's take the first one, right? The first one being hydrogenation. Again, we've said it's the addition of what? Of hydrogen gas there, H2 to an alkene, right? The example that we are having there is in a form of a structural formula, right? So we said you're always going to be having compound A, or the first compound is a double bonded compound or an alkene. Here it is, it has a double bond. What is going to happen here, grade 12, is that this double bond is going to be broken, or at least one of them. It's going to be broken, and elements or atoms are going to attach itself. So if it gets broken, it's going to be broken, then the carbon will have what? Sort of an extra bond that was not there, as you can see here, because remember, carbon must always have 4 bonds around itself. So if you break this one, it means those bonds will attach themselves to the carbon, and then this hydrogen, one of the hydrogen will go attach itself here, the other one will go and attach itself here. And as a product, we are now going to have a product of carbon, right, with 3, each carbon having 3 hydrogens. One carbon taken from the hydrogen gas and the other one taken from the hydrogen gas as well. So the main idea here is that the double bond will be broken, and then that inorganic compound here will attach itself to what? To the bonds that are now new on carbons, right? Okay, so this is how it's going to happen. This is going to be the case even if we have more than 2 carbons. Say, for example, this is ethene. Say, for example, we use propene, right? In that propene, the double bond will be broken, new bonds will be formed on the carbon, and then the hydrogens will go and attach. Then you will have one product, okay, of an alkane, okay, because a double bond has been broken. So this changes to become a what? An alkane, what we call a saturated compound. Okay, this one was unsaturated. This one was unsaturated because it contains a double covalent bond between the carbon atoms. So this one started being unsaturated, hydrogen gas was added, and then there was a break of this one of the bond, and then the compound became what? Saturated. So we go from unsaturated to what? To saturated. Okay, right. So, but for this reaction, grade 12, to take place, there are conditions that must be met. Okay, and one of the conditions for this reaction is that the reaction needs something called a catalyst. Okay, so what is the catalyst? Well, a catalyst is a substance that simply I'm going to put it generally because I'm not going to say lowers the activation energy, but I'm going to say it's something that simply speeds up the reaction, even though that's a general way of putting it. But the catalyst is something that speeds up a reaction. So this reaction will be very, very slow, grade 12, if we do not put in a catalyst. So this reaction needs something that is going to speed it up, and that is a catalyst that we are going to put there. Okay. Now we have types of catalysts that we can use. In the example that I have here, the catalyst that has been used is nickel. As you can see here, we have nickel as a catalyst, okay? But also other catalysts that could be used are platinum, palladium, and also nickel, okay? So it's important that we know the conditions, because these conditions can be asked in an exam to say, give us the conditions for this type of reaction. When you're looking at the reaction, you find that it's hydrogenation. So you must be able to know that they need a catalyst, and that catalyst could be platinum, PT, molecular formula there, palladium, PD, or nickel, Ni. Okay? Right. Now, the product that is formed, as we've always say, is always going to be what? An alkene. So you're always going to go from alkene to alkane in a hydrogenation reaction. Okay? Now, after you have drawn the structural a molecular formula or equation here, you should be able to also do it by using molecular formulas to say C2H4 plus H2 will always give us what? C2H6. This is the molecular formula or the equation written using molecular formula. This one is the equation written using structural formula. Okay, you should be able to do this. You should also be able to identify this. Say they don't give you the H2 in a flow diagram, as your questions are mostly going to be in a flow diagram. You should be able to see that we started from unsaturated to a saturated. We started from having only 4 hydrogens. Now we have 6 hydrogens. What is it that must have been added here? It must have been 2 hydrogens as well. So those are the types of mind games that the examiner is going to try and play with you here. But as long as you know your basics, you should be fine. Grade 12 then. All right, let's move on to the next one then. Our next reaction that we are looking at is halogenation. Okay, as we have said there should be a nation of halogens. So it means we are reacting an alkene with a halogen. Okay, or a halogen gas specifically. It should be halogen gas because it's always going to be reacting with a halogen gas. Okay, so the reaction of halogen gas with a compound is halogenation for addition. It's a type of an addition reaction. Okay, how do we see that it's a type of an addition reaction? One of the compound is an alkene, okay, added to be some compound, and then we form one product, which is C. And this product and the double bond in this product has been what? Has been broken. That's how we see that this must be what? An addition reaction. Okay, so what is being used here? We are using ethene again as our example, right? And here we are adding chlorine gas. This is chlorine gas, because you should also know it in weights. Sometimes they'll say write it in weights. So this is chlorine gas. So chlorine gas is being added here. So what is going to happen here, grade 12? Again, the double bond will be broken. So this double bond will be broken. The double bond gets broken. It is going to attach itself to the what? To the carbons. It is going to attach itself to the carbons. When it attaches itself to the carbons, it is then going to attract these chlorine atoms. They are going to go there and attach themselves in that compound. This is the reason why we form only one compound, because there is no swapping of places here. They both go there and they attach themselves into one compound. And we are going to have ourselves a what? A haloalkane as the final compound here. Okay, as you can see here, the chlorines have attached themselves. This is going to be the case again, even if it was more than 2 carbons. If maybe it was 5 carbons, we are having a pentene there, right? That pentene, 1 carbon there is going to what? Is going to be broken, and then the chlorines, or even if it was the bromines, will go and attach themselves there, forming one compound, which is a haloalkane. Okay, right. Let's look at something again. We're having an alkene here, which is unsaturated. Again, all right. But when you look at your product there, you find that the product is now what? Saturated. Again, we must be saying something. When we are dealing with addition reaction, the reactant is unsaturated, but the product is what? Saturated. So that's another way of seeing that we're talking about an addition reaction here. If you look at the reactant being unsaturated and the product being saturated, addition reaction. What type? You look at B. What is being added? We are adding a halogen. So then, or a halogen gas. So then it must be a what? A halogenation. So those are the things that you look at and check there, grade 12. Like any other reaction, the reaction has conditions that it needs for it to what? To proceed. Okay, so this reaction here needs to proceed in an unreactive or inert solvent. So it needs to proceed in an unreactive or inert solvent. So basically, if not, without going into too much detail there, we just mean that we need a solvent that is not going to form part in the reaction. The one that is not going to try and also react with this compound, right? The the reaction is only going to be between the alkene and the halogen gas, but the solvent will be part of the reaction itself, but it's unreactive. Unreactive meaning it does not want to react, does not want to form part of this, so it becomes neutral between these two substances. So in general, that's what we mean. So the reaction there, or the condition, is that we need an unreactive or inert meaning that it's fine, it's full, if I'm putting it in general there, inert solvent. And we also say that this reaction really proceeds very easily at room temperature. So it just needs room temperature for this reaction to just proceed. Okay, and we are saying the product formed always there are going to be haloalkanes. The products that are going to be formed are haloalkanes. As we can see, we have an alkene here, but our product is haloalkane. So that's another way of seeing that you are dealing with a halogenation. One, the reactant is an alkene, has a double bond. You check the product, it's a haloalkane. Well, this must be a halogenation. Okay, but there's another thing else you must check. B, which is the compound, to actually confirm that it's a halogenation, because if we look at hydrohalogenation, we will notice that it also behaves similar way. Okay, which is where we are right now. The third type of addition reaction, grade 12, which is hydrohalogenation. That type is hydrohalogenation. What is happening in hydrohalogenation? We are adding, remember I said you are always going to check B. What is being added in B, or compound B, or the second reactant? What is being added? That will tell you the type of reaction. So here in addition, we are adding a hydrogen halide. That means we are adding a hydrogen that goes with a halogen. That's hydrogen halide in full, okay? HCl or HBr, hydrogen halide. We are adding it to in what? In alkene. Why? Because all addition reactions, we are always going to be adding in an alkene. Alkene is always going to be our primary reactant. Okay, so if you look at this one here, we are having a propene here, which has a double bond. Okay, now I want you to pay special attention here, grade 12, because this part is very, very important. See, turns out that if we having this reaction, right, there are two possible products that could be formed in this reaction. Two possible products that could be formed. Let's look at it and explain. So we are going to have a double bond that is broken here, and then we are going to form a new bond. Right? You remember, double bond broken, new bond formed in carbons, so that the carbon becomes heavy. Okay. Now we have a problem. Okay. What is our problem? We now want the H, because it's unlike the first hydrogenation. It was both hydrogens. So whether this one was taking the other hydrogen and this one was taking the other hydrogen, it was fine. There was no problem with it. Okay. Similar thing with the halogenation one, right? It was both halogen atoms. So which one takes which chlorine is fine. The chlorines are the same. However, here we have a problem. We have hydrogen and we have bromine. Okay. So the problem is now between these two carbons, which one takes the hydrogen and which one takes the bromine? That's where the problem starts. That's why we end up sometimes having to say, yeah, two possible. Because if you say that this one takes the bromine and this one takes the hydrogen, and another person says this one takes the hydrogen and this one takes the bromine, then you are having two products there. Okay, so that's why I'm saying there are two possible products. Okay, so which product are we going to take and what is going to govern us there? So there's a rule that we use called the Markov-Nikov rule. Did not write it down here because we really don't need to maybe memorize it or know it. It's not part of our examination guideline. However, we need to be able to what? To apply it. Okay, so Markov-Nikov rule tells us that the carbon that already has more hydrogen, right? The carbon that already has more hydrogen between the two carbons. Remember, we don't consider this one. Between the two carbons, the one that has more hydrogens will take the hydrogen. So the hydrogen will be attracted where more hydrogens are. Okay, and then the carbon that has less hydrogens will then get the halogen. Okay, so telling us that this hydrogen will come and attach itself here, and the bromine will come and attach itself here, right? Most people say the rich gets richer and the poor stays poor, okay? Meaning that this carbon was already rich with hydrogen, but it is getting yet another hydrogen, so it's getting richer. And this one was poor, only having one hydrogen. It stays poor by not getting a hydrogen and only getting what? A bromine. So that's one way of remembering it, okay? So it means the actual product that will be formed here is this one. We call it a major product, okay? Because almost all the time when this reaction is occurring, this is the product that will be formed. But sometimes you get that this product might be formed there and there. So hence it is called the what? The minor product. Okay, so if the examiner asks you to do this reaction, okay, and you write it out, grade 12, see, what you are going to do, you are always going to try and form the major product. That's what I'm telling you to do. Always try and form the major product, unless it is stated in the question itself that they are looking for the minor product, okay? So if they just say, what are the products of this reaction of propene reacting to hydrobromine here, then you are going to form the what? The major product. Go for the major product. Always grade 12, okay? Go for the major product, unless they state to you or they tell you that we want the minor product. In that case, you just simply swap, okay? I hope everyone understands me. What I'm saying here is that we have two possible ones, but the one that will be formed the most is the major one in this reaction. The one that will be formed the most is the major one. Hence, it is the one that we are going to be going for. So always form the major product. And how to do that? You say the carbon that already had more hydrogen takes the hydrogen, and the carbon that had less hydrogens take the halogen, which is the Br in this case. And this is how you form a product. So that this means our reaction will look something like this. Okay, if we were to write the molecular formula of this reaction, it will be C3H367 and a Br plus HBr, and this gives us, because it's an addition, there's only one product. We have C3H7 again, yes, and Br. Okay, right. So this is what we are going to get. Oh, sorry, I'm making a mistake. I'm already including the HBr here that I put there. These ones were not there. The Br was not there, and the 7 hydrogen was not. So it was H6. Sorry, it was H6. C3H6 plus HBr, giving us C3H7 with the Br, already including these ones, which is incorrect in this case. So this would be the molecular formula of this reaction, hydrogenation. That would be the third type, okay? Now we are talking major product and minor product halogenation there. Let's look at the fourth type. But before we look at the fourth type, we forgot to say every reaction has conditions. And what are the conditions for this reaction? This reaction, for it to occur, make sure that there is no water present. No water present. And again, this reaction needs an unreactive or inert solvent, like the previous one. Unreactive or inert solvent, but they must make sure that there is no water present. Then this reaction is going to proceed. And the products that are going to be formed always here in this reaction are haloalkane, like was the case with the halogenation, the haloalkane. So that tells you it's very important to look at what? At compound B. Check what compound B is. Hydrogen, halogen, hydrogenation. Okay, simple as that. All right, so let's move on to the last addition reaction that we are going to look at, which is going to be addition reaction. Okay, sorry, no, it's going to be hydration. The last addition reaction or type of addition reaction is hydration. Okay, in this case, we are having the addition of water to a compound. What compound? In this case, it's always going to be an alkene, because addition reaction. For us, addition reaction is alkene, or we are adding alkene there. Okay, so here's our example again. Here we are having again here a propene. Okay, and then this propene is being reacted to with what? Water, HOH. This is the better way of drawing it when you are drawing structural formulae, right? Write it H-O-H here. Show the bonds, indicate the bond between the hydrogen and the oxygen. Okay, right. So how do the product get formed here? It's an addition reaction. Again, we are going to have an issue of breaking one of the bonds. And if we break one of the bonds, we are going to have new bonds forming on the carbon atoms. Okay. Now, again, we have a similar problem if you are looking at it here. Okay. So, what is happening? In water here, this bond is going to be broken, right? Or separated these bonds here. We are going to have the hydroxide, right? And the hydrogen being separated, okay? And then one of the carbon here must get the hydrogen and the other carbon must get the hydroxide, okay? Now, the question arises again, like we had a question with hydrohalogenation. Which one gets the hydrogen? Which one gets the OH, hydroxide, right? That's the question, right? And how do we answer that question again? Again, we go back to Markov-Nikov rules. The rich gets richer and the poor stays poor. The rich gets richer, the poor stays poor. The carbon that had more hydrogen will take the hydrogen, while the carbon that had less hydrogen will take the OH. Very, very simple. So hydrogen goes to this carbon and OH goes to this carbon. This, what we are forming here, this is an H by the way, this what we have formed here is your major product. Here it is here, okay? Here it is being formed here. This carbon took the hydrogen, here is the hydrogen, it was only 2, remember? And this one took the OH, okay? And what we are forming here is what we call the major product, the product that will be formed almost all the time when this reaction is happening, okay? There and there, the minor product might get formed, okay? So if they are giving you a propene and they are saying it's reacted with water, okay? Then they say, give the product of the reaction maybe. You are going to give the major product. Always go for the major product unless it is stated otherwise that the examiner is looking for the minor product. I'm not saying we must ignore the minor, but I'm saying we focus more on the major product unless it is stated otherwise. If they want the minor, then you simply swap. Wherever you had hydrogen, you put the OH. Wherever you had OH, you put the hydrogen. So let's not forget here that we have two products that could be formed, but one is minor, meaning it is formed less than the other one, which is major. That's the major product that is formed then. And the issue here is which carbon gets what. One carbon must get hydrogen, and the other carbon must get what? The OH. And if one carbon gets the OH, and you are seeing here, the OH is a functional group that tells us that now we are dealing with an alcohol. So during hydration, the product that will be formed will always be alcohol. Grade 12. So that's another indication or another way of seeing that addition was taking place here if the product was alcohol and we are coming from an alkene. Okay? So what are the conditions for this reaction? Well, this reaction again needs a catalyst. Like we were talking about the reaction, the first one, hydrogenation. It needed a catalyst. What did you say a catalyst is? This is the substance that speeds up a reaction. Substance that speeds up a reaction in general that makes the reaction to be faster. Okay? Or increases the rate of reaction. We can maybe put it like that. What type of catalyst could be used? Well, we can use the sulfuric acid, H2SO4, or the hydrogen phosphate here, H3PO4. These are the two catalysts that could be used. Again, this reaction will need to take place in excess water, needs excess water if the reaction is hydration. So one of the conditions is that this reaction needs excess water, a lot of water there. Okay, I hope people are getting the the idea behind the addition reaction. And from the structures themselves, you should be able to now write the molecular formulas and write a chemical equation using the molecular formula. Okay, without again waste of time, grade 12, let's continue and take the other type of reaction. This is the third type now. If you remember, we looked at combustion reaction or oxidation reaction. Then we looked at addition reaction, but we found that addition reaction had different types, 4 that we have looked at. Okay, now we are looking at the third reaction, which is substitution reaction. It also has different types of reaction within itself. What happens during a substitution reaction? The word says itself, substitution. What are you doing when you are substituting? You are taking one thing and you are replacing it with another thing. That's what happens during a football match. Okay? If you're a person who watches football, you know that there's a time where they are going to say, let's check out this player. It looks like he's tired now, and let's put in this player. They are substituting one player with another player. That's substituting. So during a substitution reaction, there's going to be the swap of atom. One atom moves, the other atom goes where the other atom was. Swap there and substitution. The substitution reaction always takes the form A plus B gives us C plus D. Okay? Because it's unlike the addition when one was attaching himself on the other. This is not what is happening. Here we are simply swapping. Okay? So if I had 2 reactants, I should also have two products, because we just simply swap some atoms then. This is what happens during a substitution reactions. So there are 3 types of substitution reactions that we need to look at grade 12. One being halogenation, okay, a type of halogenation, okay, and in this halogenation, what is happening? We are having a reaction of alkanes with halogens in this one, okay. Number 2, we are having a reaction of alcohols with hydrogen halides, and number 3, we are having hydrolysis. Okay, so let's quickly look at them individually and see what we are talking about here. So in halogenation, in a substitution reaction, because we also have halogenation in addition, that's when we have a reaction of an alkane, right? And then this alkane is reacting with a what? A halogen. Hence we are calling it halogenation, because a compound is reacting with a halogen. But here we are forming a what? A haloalkane and a hydrogen halide. So here we cannot have one compound being formed, because we were not breaking any double bond. We are simply swapping. Example there, here, if maybe we will get this methane here and we react it to this bromine gas. Okay, right? What is going to happen? One of the hydrogens, maybe this one, will be removed. Okay, and then this hydrogen will now be replaced by one of the bromine atoms. Where there was the hydrogen, the bromine goes, and where there was a bromine, the hydrogen goes, substituting each other. Hence, we are calling it a substitution reaction. So now we are now having products such as a what? A haloalkane, yeah, and a hydrogen halide. Okay. Now, how do we see what's happening here? Okay, there are clues that can tell us that this is the reaction we are looking at. One, it's the reactant. The reactant must be a halogen gas. If the reactant is a halogen gas, then that's one clue that tells us we are dealing with this. Okay, but now in the first one, it was also a halogen gas. So what's the difference? The difference is here. On the first one, the halogen gas was being reacted to an alkene. Okay, the halogen gas was being reacted to an alkene. Here, it's being reacted to an alkane. Okay, an alkane reacting to a halogen gas. A halogen gas. So, if it is reacting to a halogen gas is being reacted to an alkane, then that tells you that we are dealing with a substitution reaction. But if it is reacting to an alkene, that's an addition reaction. I hope you can tell the difference between them. Again, products can also be a clue of the fact that we are talking about a substitution reaction. If we are having 2 products, product C and product D here, then again, there's another clue that tells us we are dealing with a what? a substitution reaction. But then again, by looking at what was happening, here I had carbon with 4 hydrogens. Now I'm having carbon with 3 and a Br. Where did this Br come from? Definitely it came from here, because wherever I had a Br, now I have a hydrogen. So there are atoms that have swapped places here. A clear indication of what? Of a substitution reaction. Halogenation specifically, that substitution reaction. Like other substitution reaction, this reaction takes place or has conditions for it to take place. Okay, and the condition here is that this reaction needs to have UV light, either UV light or you give it heat. Okay, as you can see here, UV light is an indication of the condition that is needed for this reaction to take place. This reaction could also be written using molecular forming, which you are going to say CH4 plus Br2 will give us CH3Br plus HBr. Okay, and I want you to notice when we are doing the structure, there are bonds here that are connecting the Br and the Br. When we are doing structural formulae, we don't write the Br2 like this. We write it like this. We don't write HBr like this. We write H bonded to Br. That indicates that we are talking structure. We indicate the bonds. So that would be an example of a substitution reaction. I always remember this substitution reaction like this. I always say to myself, it's a substitution reaction where an alkane reacts with a halogen to form a haloalkane. That's how I always remember it myself. Okay, because that alkane is important. It's an alkane. It's not an alkene. If it was an alkene, it would have been a what? An addition reaction. Want us to also check something here. The reactants here are saturated. Okay, and the product here is also saturated. Another thing or clue that you can use to see that we were dealing with a substitution reaction. Remember, in addition, it was always unsaturated going to saturated. However, here it's saturated still going to saturated. So that's one way of always seeing or checking what type of reaction you are dealing with. Grade 12 learner. Okay, right. So let's check the second type of substitution reaction. Okay, the second type of substitution reaction, we're dealing with reactions where we are having an alcohol reacting with a hydrogen halide. Okay, and again we are going to form haloalkane. On the first one, we're forming a haloalkane. Again, here we're also forming what? Haloalkane with water, taking the form A plus B will always give you C plus D. Okay, right. So this reaction usually takes place easily when we are having alcohols such as tertiary alcohol. What is a tertiary alcohol? You might ask yourself if you don't know already. A tertiary alcohol is an alcohol where the carbon that is bonded to the OH is also bonded to 3 other carbons. That is a tertiary alcohol. For example, an alcohol that looks like this will be considered a secondary alcohol. Why? The alcohol or the carbon that is bonded to the OH is only bonded to 2 other carbons. Therefore, we say this is a secondary alcohol. An alcohol that looks like this will be considered to be a what? A primary alcohol. Why? The alcohol that is bonded to the OH is only bonded to 1 other carbon. Primary alcohol, secondary alcohol, tertiary alcohol. For these type of reactions, usually tertiary alcohol is used there. So this is a tertiary alcohol because the carbon with the OH is bonded to 1, 2, 3. And when I say bonded, I mean directly bonded, because this one, it is only bonded to 1. It's not directly bonded to this one. I hope you understand me, grade 12 learner that does not know the difference between primary, secondary, and tertiary alcohol there. This one is directly bonded to this carbon and also this carbon. Okay, but this one is only directly bonded to this carbon, not to this one. Hence, this one is primary, this one is secondary, and this one is tertiary alcohol. So this reaction usually takes place with tertiary alcohols, grade 12. And what are we seeing here? we are seeing that one of the reactant is a what? A hydrogen halide. Okay, a hydrochloric acid there, HCl, that is taking place. However, there is no double bond that is being broken here. So we can't be having HC attaching itself in this compound. We're not going to have that case, right? What are we going to have here? We are going to have a swap of compounds, okay? We are going to have a swap of what? Of compounds here. We're having an alcohol reacting with this. So we are forming a haloalkene. There's only one way to form a haloalkene here. It's by taking this Cl, taking it here, and removing the OH, because this is the only thing that will disturb this from becoming a haloalkene. So we must remove the OH, take it where the Cl was. Now what we end up having? We end up having a C that is bonded to CH3, condensed structural formula here, CH3, and now we are having Cl, okay, plus here HOH, okay. This is how now this OH comes from here, and then the Cl comes from there. They have swapped places. They have substituted, a substitution reaction then. What are the condition reaction or the conditions for this reaction? You might ask. This reaction requires heat. This reaction requires that there must be heat. Great talk. So this is the second type. The first one, we were forming a haloalkane by using an alkane and a halogen. Okay, it needs UV light or it needs heat. Okay, forming haloalkane by using alkane and halogen. The second one, we are forming a haloalkane by using alcohol and a hydrogen halide. HCl, sometimes it could also be HBr. Again, we are forming a haloalkane there. It's a substitution reaction. Saturated was the reactant, saturated are the product. So saturated to saturated, again, like we said, in substitution reaction, unlike in addition reaction where it was unsaturated to saturated. Here we are having saturated, going straight to saturated yet again. Right, let's look at the last one there, hydrolysis. Okay, and hydrolysis here is the reaction of the compound with water. Well, for us specifically, hydrolysis is going to be a reverse of this reaction that we just had here. Here we were forming a haloalkane from alcohol and hydrogen halide. Okay, in hydrolysis, we are going to be forming an alcohol. Hydrolysis, we are going to be forming an alcohol from a haloalkane in hydrolysis for our scope grade of technical science. Hydrolysis is broad, it's just reacting a compound with water. But for us, we're going to be having a haloalkane, for example, one that looks like this. Right, let's use 3 carbons. And I want us to put Br here. This is a haloalkane. Now, this haloalkane must be reacted to something, okay? And the aim here is that we want to form an alcohol, okay? And how are we going to do that? The haloalkane must be reacted to something. What is the thing? The haloalkane must be reacted to a what? A dilute strong base, such as sodium hydroxide, NaOH. It must be reacted to it, okay? Right, then what are we going to form as the product? It's a substitution reaction. We are talking about saturated reactant here. It's saturated. Once the reactant is saturated, that's a substitution reaction, okay? Addition reactions, all of them, the reactant was unsaturated. So this is saturated. Substitution reaction. What are we trying to form here? Alcohol. There's only one possible to form alcohol here, grade 12. Get rid of the what? Of the halogen that is making this a haloalkane. Let's get rid of the halogen. And for us to have alcohol, we need an OH, grade 12. So if I get rid of the halogen, I must go and look for an OH. Well, what do you know? Here's the OH in NaOH there, my dilute strong base. It's a substitution reaction. So this one goes where this one was, and this one comes here where the Br was. They exchange places, they substitute. Therefore, our product becomes C, right? The hydrogens would remain where they were. Now, where we had a Br, we now have an OH, okay? And now we have a what? An alcohol. But remember, the substitution reaction takes from A plus B is equals to C plus D. So this would be C, and our D will be what? An ABr. That's what we'll be forming then. So we now have that alcohol. We have substituted. And remember, you are trying to do these things and you are thinking about them in those flow diagrams that they are going to give you when they are asking you these questions, grade 12. Okay, right. These would be our hydrolysis. Okay, reaction conditions for these reactions is that this reaction will always need what, or require a dilute strong base, to require a dilute strong base. And there are options for this dilute strong base. You could use NaOH or you could use KOH. Okay, those are the ones that mostly are going to be used. Sometimes they are going to use H2O. Sometimes they are going to use H2O. It can also work as well. Advice to you, grade 12 learner, if they want a dilute strong base from you, only go for these ones. Do not go for this one. Let the examiner be the one that uses this one. You only use NaOH and KOH. That is going to make your life simple and easy. Another reaction condition that is needed then is mild heat. Also need mild heat then. So this is one if they ask for conditions for this reaction. Dilute strong base such as NaOH or KOH, and also mild heat. It's important to know these reactions conditions, grade 12. It's very, very, very important. All right. Okay. Now let's try and look at an activity quickly and see if we can use whatever we have learned to sort of answer questions here. So here we have a flow diagram where in the center we have ethene. Already, whatever reaction comes from here, I know must be an addition reaction because it is coming from an alkene. There is no other way. Whatever reaction comes from here must be a what? An addition reaction. Reaction A, the product is alcohol. This must be hydration. The reaction A, the product is alcohol. This must be a what? A hydration reaction. Okay, I see by looking at the product. Okay, so but I can also ethanol. I can also draw the whole structure. Okay, to try and find out the whole thing. I go to B, look at the type of reaction that is there. I go to C and try the same thing, but all of them I see they must be addition. And then I also go to C. They say excess gas X. Well, combustion, excess gas S. This must be obvious to me. The gas is in excess. It must be in oxygen. Let's look at the questions that they are asking them and check if we'll be able to answer them. The flow diagram below shows how ethene can be used as a starting reactant to manufacture a variety of organic compounds. Letters A, B, and C represent different types of reaction. Name the type of addition reaction in capital letters, the type of addition. So you can't say addition, addition, addition. They say name the type of addition reaction. A, B, and C. Right? I want to go through all the questions first. Right? For reaction A, write down the name or formula of the catalyst used. If you remember those catalysts we spoke about. Use structural formulae to write down a fully balanced chemical equation for the formation of ethanol. Balance for the formation of ethanol, a chemical equation. And then as we continue here for reaction B, write down the formula for the inorganic reactant that is needed. We spoke of that one. Write down one condition for the reaction to proceed. And then for the combustion reaction, write down the name or formula for the excess reactant gas X, which should be oxygen. Name or formula of the product that are formed. Products that are formed should be very, very easy. Your answers should be as follows. That one was hydration. The hydrohalogenation would be B, or hydropromination. I would prefer that people stick to hydrohalogenation. C, hydrogenation, right? Compound A, you could use sulfuric acid, okay, as a catalyst. And there is the structural equation, or equation using structural formulae. There is how you can draw it there, okay. And then for reaction B, HBr was the inorganic reactant, inert solvent or unreactive solvent, or no water present, excess oxygen gas, product, carbon dioxide and water, as we said, will always be the case. Okay, so I hope people understand what we were talking about here today, right? I would also like people to try this flow diagram, which is a bit more complicated than the other one, as their homework, and try and see if they are able to answer these questions. All right, I want to quickly run through the summary of the reaction. Okay, so what we looked at here, we looked at the types of reactions as oxidation or combustion reaction. We looked at addition reactions, all type of addition reactions being hydrogenation, halogenation, hydrohalogenation, and hydration. We also looked at substitution, the type of substitution reactions, where we're having a reaction between alkanes and halogen to form haloalkane. Also a reaction between alcohol and halogen to form halogenation again, or haloalkanes again, sorry. And also a reaction between haloalkanes and a dilute strong base to form an alcohol or hydrolysis there. Okay, and we will also write down the chemical equation for the combustion of hydrocarbons in excess oxygen. We also identified reactions as addition or substitution. We were writing down using structural formula or molecular formulae the chemical equations for addition reactions and also for substitution reactions. We were also looking or writing down the reaction conditions for each reaction. If you know all these things and you are able to do them in this particular order, you should be able, it should be fine. What I would task you to do the grade 12 is start by the combustion reaction. Make sure, I'm still emphasizing and pleading with you, not even one of you should ever get that question wrong. Make sure you get all those marks, 3 marks, and then start by going to the addition reaction and substitution reaction. Do a lot of practice using questions from previous question papers, and then you should be fine looking at all those flow diagrams. All right, our preview for our next lesson, which is going to be on the 25th of April, is that we're going to be doing electronic properties of matter that day. Thank you.